Hello, my little mathematicians. Today I'm going to do the evaluating solutions and writing stories warm-up with you. You should know how to do all this already, so at any point in time, please pause the video, try it, and then unpause it and check to see how you did. All right, so for the first ones up top, when you want to check to see if something's a solution, what you do is you have the same exact equation. The only thing that you change is that I'm going to substitute in what they tell me for my variable and then check to see if it makes a true or untrue statement. So I plugged in 7 for x, and then I'm going to see if it makes a true statement or not. We'll simplify the left. 3 plus 7 is 10 equals 12. Is 10 equal to 12? Nope, not a true statement, which means that 7 is not the solution. Okay, here you have 28 divided by, they think that 6 is the answer. Let's see if they were right. 28 divided by 6, if you type that into your calculator, you get 4.6 repeating. Definitely not equal to 6. So nope, 6 was not the answer. Here, when you have a variable touching a number, that means they're being multiplied. And they think that 3 is being multiplied with a 9. Let's see if that's true. 3 times 9 is 27. Bring down the other side, equals 27. True statement. So yes, 9 was the correct solution for that variable. Okay, on this side, 29 minus, what do they think n is? They think it's 14. So if I type that in, 29 minus 14, I get 15. Does 15 equal 15? Yes, that is a true statement. So 14 is indeed the solution to plug in for that variable. Okay, next one. They want to replace the variable with 36, and they're asking, hey, is that the right answer? Well, let's test it. See if it makes a true statement. 36 divided by 6 is 6, equals 12. Is that a true statement? No, it is not. All right. Tricky one. Okay, 3 times something plus 5 equals 16. Let's see if they got the something right. They think that the P is a 3. Well, 3 times 3 is 9, and 9 plus 5 is 16. Bring down the equals 16. True statement. So yes, 3 is indeed the right answer for P. Okay, hopefully you did fairly well on those. Now for these ones, please notice the directions say select all the math problems that could be written about this particular equation. Okay, I think it's easier. Sometimes I write the equation for this and then compare it to see if they match. Okay, so it says Arya bought 28 apples and a couple of pears to make some fruit pies. And then in total, he bought 55 fruits. Okay. So you bought 28 apples plus some amount of pears we don't know. And in total, that's equal to 55. Okay, well, this matches this exactly. It's just the P is an X. And yeah, they just changed the variable. And you can make the variable be whatever you want, so it works. Okay, now I'm not done because it says select all that apply, so there could be more. The next one says Ben is training for a race. After 2 weeks, he has run 55 miles. If he ran 28 miles in his first week, crazy person, how many miles did he run in the second week? Okay, so the total that he ran was 55, and that's equal to 28 in the first week plus some unknown amount in the second week. That is exactly that. They just flipped where the 55 was. So like they just brought this side to the left and they brought that side to the right. So still equal, right? Yep. Okay, the next one says Caleb throws a birthday party. He buys tacos for 28 and burritos for 55. How much was the total cost for the food? So he bought something for 28 plus something for 55, and then that's going to be equal to the total. Not the same thing, because like in an instance, this would be the variable, the total. So the cost of the tacos plus the total equals the amount he paid for the burritos? No, doesn't make sense. Okay, Daisy works on homework for 28 minutes, then decides to take a break. If she spent a total of 55 minutes on her break, how long has she been doing homework? She works on it for 28 minutes. Okay, she takes a break. She spent a total of 55 minutes on her break. How long has she been doing her homework? That is a total trick question. They're just asking how long has she worked on homework. She worked on homework for 28 minutes. No equation needed. Well, bam. Okay. Ella and her friends collect figurines. Ella has 55. Frank started out with 28, but bought more so he can have the same amount of figures as Ella. Okay, so he has the same amount as her, which is 55. He wants that to be equal to, how much does he already have? He has 28 already, plus however many more he buys. That many figurines will be equal to the total of 55. Yep, this equation matches that one. I just had an F for figurines and they had an X. So there we go. That equation would work as well for that story. Okay. So again, remember, as long as like the equations kind of match, the variables don't need to match because you can plug in whatever variable you want. Unless it's on a computer, you probably want to type in an N if that's what it tells you, or type in whatever it tells you to type in. But if it doesn't tell you a specific letter to use whatever you want. Now this one is the opposite. This time they gave you a story and you have to see which equation you could use to solve it. And as we know, there's more than one equation that you could use when trying to figure it out. Now there's not an unlimited amount of equations, but there is more than one. So let's see. Brooklyn went to Target and used up $96 on her gift card. Man, how big was her gift card? She now has 28 left. So how much did she have to start with? Okay, so you have some unknown amount on your gift card. And then when you use up or spend, that goes away. She spent 96, and that's equal to how much you have left. Okay, now since I have to choose a bunch of matching equations, I'm going to pick some other ones that match this. I could also say the gift card is equal to the amount that I spent plus how much was left. Okay, and then I could also say that how much I started with minus how much was left is equal to how much I spent. Okay, now let's go ahead and check which one of these equations match these, because I think that's all the different ways. Obviously, sometimes when you're subtracting, like your total has to stay the same, but you could subtract either one of these and like flip these around. And then you could take the bigger one and set it equal to these two, like added together. So you could always do the inverse of each other's. Addition is the inverse of subtraction. Obviously, if we see any division or multiplication ones, they're probably not going to work with these numbers. So any 2896 with multiplication or division, we know that those are our traps. Okay, I think those were the only ones. All right, the rest we have to see a little bit more carefully. Okay. Variable minus 96 equals 28. Yep. 96 minus 28 equals, no. So how much I spent minus how much I have left equals the total. That doesn't make sense. Okay, my gift card is, yeah, this is the same as this. They just flipped it around, so that's okay. How much I have left plus my total equals how much I spent. That doesn't make sense. Okay, this minus 28 equals 96. Yep, have that one right here. How much I spent plus how much I've left equals the total. Yep, that's the same right there. Beautiful. Okay, hopefully you got the same ones that we did. And then the last one says, write a story that can represent the following algebraic equation. So definitely pause it, try to come up with some scenario, and then unpause it. Okay, now that you're back with us, I mean, obviously I can't even give you all the answers here. There's an infinite amount of possibilities. But as long as you have any relationship where you need to multiply 10 with your variable and then add 9 to it for a grand total of 47, you're going to end up with the right answer. Okay? But hopefully your story was very entertaining. I look forward to reading them. All All right, my little mathematicians. Um, Main thing to keep in mind is read those directions. If they ever say select all that apply, don't just stop after you find the first one. Keep going. And then remember, if it's talking about like addition or subtraction, then those inverses of each other are going to work. But obviously, you can count out like multiplication or division if it's an addition or subtraction equation. And then if it's vice versa, if it's a multiplication or division equation, you can cross off all the adding and subtracting ones. Okay. All right. You got this.